Hello, this is Balvan. So this is Lab 2 program. So here let's start with the code. So here I have declared a procedure, addressing procedure, and then I have moved the values 10 to AL register and 2 to BL register. After that, we are using a register addressing mode. What is register addressing mode? It's basically where we pass two registers with the opcode. So like here in the comment here's the comment. You can see that add is the opcode and register 1 register 2 are the operands that we use. Okay, so register 2 values get added to the register 1 value. That's what register addressing mode. So here what we are doing is, so here add is the operand and AL comma BL, both of them are registers. So AL is containing 10 and the BL is containing 2. Okay, so when we'll add values, so they'll then the BL value will be added to AL value, and will be stored in AL only. Okay, so 10 plus 2 will come out to be 12, and that will be stored in AL in hexadecimal value. Okay, as an hexadecimal value. After that, we are subtracting values. So AL minus BL. So AL is containing 12. 12 minus 2 will be come out to be 10. We'll see after emulating it, but I'm just explaining it how will it work. Okay, so this will be, so here 12 minus 2 will be 10. Okay, so AL will contain 10. After that, as we know that the division, how does division works? It will basically divide the value of accumulator with the register, which is the register value. Okay, which we are passing here. So as BL is containing 2 value, and it will automatically divide accumulator value, which accumulator is containing. So accumulator is containing 10 after subtraction, so it will divide 10 by 2, and that will come out to be 5, and that's how multiplication will be done in the same way. It will also multiply the value of the accumulator only with the register that we have passed, and this register is containing some values, and that is 2, and this will multiply the value of the accumulator, which is containing 2, and then the result will come out to be 10, and that will be stored in AL only, that means accumulator only. Okay, after that we are doing the immediate addressing mode. And what is immediate addressing mode? What we do in this is, we just pass the value directly pass the value to the register. Okay, so like here what we are doing is adding a value. Okay, adding value to the register 1, and what value we are adding? The value that we are passing with just the side which is we have written. So the value which we are passing will be added to the register 1, and that will be stored in the register 1. That's how immediate addressing mode works. Okay, so in case of addition, so AL is containing some values. So after the register addressing mode part, this will contain AL will contain some values, and what value it will be? It will come out to be 10 only, because after that we were getting the value 10. Okay, so AL is containing 10, and then we are adding 6 directly. So this value 6 is what the directly immediate addressing mode, we are directly passing the value to add into the register. Okay, so it will add 6 to the register AL, and it will store in the AL only. Okay, so 6 will be added to 10, and that will come out to be 16, and will be stored in AL only. Okay, and then we are subtracting it again, subtracting also. So what will it do? It will also subtract value 4 from AL register, and then we'll store the value to the AL only. Okay, and division multiplication will work the same way as it was working on the register addressing mode. And how values will be changed, we will see it after emulating it. Okay, and now the main thing here is, when we talk about an indirect addressing mode, so how indirect addressing mode works. Okay, so in case of indirect addressing mode, what we are doing is, we are initially I just forgot to mention a comment here, that what we are doing is, here we are we are adding a passing a what we can say, we are moving a value to this address, which is 500h. 500h is the hexadecimal address, and we are adding value to it, or we can say we are passing value to this address too. Okay, this is immediate addressing mode, because we are directly passing the value to a particular address, or to a particular register. That's what the immediate addressing is. and then we are moving 10 again to the AL. Okay, so here, so now how indirect addressing mode works. Okay, so let's see. So what's the basic idea we use in the indirect addressing mode is, like here you can say in the comment section part that add is the opcode and register one, we where register one is the register which will contain some value, and address is the address where the value will there when at which there will be a value, there will be some value. Okay, so at this address there will be some value, and this will be added to register one and will be stored in the register one only. Okay, so what we are doing here is adding al add al comma and this address is passed. So the address is containing value 2. Okay, so this will be added to the register al and will be stored in al only. Okay, so 10 plus 2 will come out to be 12 and will be stored in 12 and will be stored in al. And the same way al minus the value which is contained in this address, which is 2. So al is containing 12, 12 minus 2 is 10, then al will store 10. After that is the same goes for division also. So it will automatically divide the accumulator value with this address value. Okay, so here accumulator value is containing 10 and this address is containing, at this address the value is 2, and 10 divided by 2, this will give the result 5 and will be stored in al only, which is accumulator register only. And same in the same way multiplication will work. Okay, after that we are returning to the program. So let's see how will it work. Okay, let's emulate it. So here, yeah, so let's see. So single step, I will see the step by step. So like here we have moved the value 10, which is to al, and in hexadecimal 10 is represented in a. Okay, so a is added to the al. Now let's see the bl part. Now bl, yeah, the bl register we have added value 2 to the to bl. Okay, now adding al to bl, that means 10 plus 2 will give me 12. And yeah, here it is changed to c. L is changed to c. Why it's c? Because it was hexadecimal of 12 is c only. Okay, then we are subtracting 2 from it, that is it is 12 minus 2 will come out to be 10, and the hexadecimal of 10 is a on. Okay, so this was the result. Now let's see the division part. So division, what it does is it will divide al value with the bl, and bl is containing 2 and 10, then the al was containing 10, so 10 divided by 2 will come out to be 5. So this is how it's containing 5 value. Okay, now let's see multiplication. So 5 into 2, this will multiply the value with the bl register value, so it will come out to be 10 again, and that this is the, and the hexadecimal value of 10 is a. Okay, after that we are going to immediate addressing mode. Now here we can see that al is containing the value 10 and bl is containing value 2. So let's add 6 to it, then it's coming out to be 10. Well, basically 10, that means the hexadecimal value. So like here al was containing initially 10, and 10 plus 6 is 16. And when we represent 16 in a hexadecimal form, it will come out to be 10. Okay, so it's a 10, that's a 16 only in hexadecimal. Okay, so now let's talk about the subtraction part. Will minus 16 minus 4 will come out to be 12, and 12 hexadecimal value is c. Okay, so this will change to c. There, c, that is changing to c. Okay, now division part. Now division part, what will it do? The c is 12 and 12 divided by 2, because bl the value is 2. Okay, now it's come out to be 6. Now 6, and then again we are multiplying it with 2, it will come out to be c. Okay, so now we are adding value at the value 2 to that address. So we have added to this address some value which is 2, and al we are again adding al, we are again adding 10 to al, so the al is changed to a. Okay, now and adding al register value which is a10 with the indirect addressing mode. So with the address which is containing 2, this will come out to be 12, and 12 is 12 is the c is the hexadecimal value of 12. Okay, after that subtracting 2 from the again we are subtracting 2 from the accumulator register, so that will come out, this is again a 12 minus 10, 12 minus 2 is 10, and 10 and a is the hexadecimal of 10. After that, we are dividing the value of accumulator with the value containing this address. So this will come out to be 5, because 10 divided by 2 is 5, and then we are multiplying it again with 2, that will come out to be again 5. So this is how the program is working. This is the end. Thanks.